For the last, decade or two, there's been increasing recognition of the value that nuclear power brings to like a mixed energy portfolio in the grid. The rising demand that we see now has totally changed the urgency of the need, and so as before we were focused on understanding what was going to replace existing generation technology, now we see a supply constrained system where the goal is to get that power to market as quickly as possible. And for advanced nuclear, those timelines are realistically going to be very challenging for the near term needs. So for Kairos and for we think what others should focus on, using the next couple of years to really establish a process of high quality project execution, establish cost certainty and schedule certainty, and use that as the springboard for enabling deployment in the 2030s. That's where I think where nuclear power can really provide the most potential. For Kairos Power, our approach has two major strategies. One is iterative hardware demonstration. So we like to do a design, build, test cycle and take that learning and feed it back in. And so we're always learning continuously around the process. Where we are right now is a significant transition in that process. So we've established a lot of confidence in the reactor systems, the hardware that will actually run the plant itself. Now we're moving into the stage where we're really starting to understand what are the factors around civil construction and modularization that are going to play a really important role in the confidence around cost and schedule for future projects. So in our facility in Albuquerque, we have a modular build right now for a non-nuclear prototype system called the Engineering Test Unit 2.0. We'll be bringing that system up online within a couple of months, and that'll be a full-scale non-nuclear demonstration of the systems that we're going to see in our first reactor for Tennessee. And then at the construction site in Tennessee, we're learning lessons every day around actual construction, civil construction, and how we are going to be more efficiently run a site with concrete and steel and kind of work with our partners in that front. So what we see right now are kind of a decoupling of key parts of nuclear project delivery. Each of them are providing a lot of real data on schedule and cost, and we're incorporating that in to understand what it's going to actually take for us to deliver our first commercial projects. The transition from demonstration to deployment has a lot of potential pitfalls, and we're really focused on trying to make sure that we are best prepared to make that transition smoothly and quickly. So for a lot of our supply chain and manufacturing infrastructure, making sure that it's scaled not just to supply the equipment that we need and materials for the first reactors, but being able to support the initial commercial deployment for really the first half dozen or so reactors to quickly follow that. That gives us a very good learning ground for scaling, and then when we move to full-scale commercial deployment, we'd look at basically expanding out production lines in series. So building the same production line for fuel, for salt, for reactor equipment over and over again. Combining that with some of the construction methods we're working on at Tennessee at the Hermes reactor, figuring out how to do precast concrete for nuclear structures. It's a conventional technology that's used all the time for parking garages and bridges and all types of different structures. But for doing it for nuclear systems just requires a little bit more care and attention to make sure it can meet all the requirements. So we're pioneering that with the Hermes 2 reactor. That will be our commercial demonstration. And then from that, we'll be able to springboard more factory production, more standardized production, to enable faster builds for the first future commercial fleet. For first of a kind deployments, we've gone through a number of iterations that have taught us a lot along the way. I think the purpose of the iterative process we're following requires you don't know exactly what lessons you're going to learn, and so in order to best take advantage of those, one has to have a combination of curiosity, but also humility. So recognizing what we don't know and that it's worthwhile to take additional time to incorporate those lessons in and really buying into that process. And so as we go into new tests, new demonstrations, new goals for the company, we realize that we don't know everything up front. We have confidence in our ability to figure it out, but we know that we're going to have to rely on our hard work as well as bringing in kind of key resources wherever we can find them to get to the best solutions. And having that level of the combination of confidence and humility it's a tough balance to find, but one that's absolutely essential, and we've found to be invaluable over 9 years. And seeing newcomers in the space trying to follow the same path, I would pass on that advice to them as well.